Hi, welcome to the lecture number 7 of the process mining course. In this lecture, we are going to discuss the process simulation and what-if scenarios, and we are going to discover how to set the parameters of the simulation models and how to perform the data-driven simulation. This lecture is composed of 3 videos. The first one is about an introduction to what is a simulation model and the different steps for performing the simulation. The second video is about a demo, how to perform the simulation inside Apromore. And the third video is about the pitfalls or the problems and limitations of the simulation and how to perform data-driven simulation. Let's start. So far in this course, we will handling as it is process mining. We were performing some automated process discovery, conformance checking, performance mining, and variant analysis. All of these approaches, they depend on an event log provided from the organization. The event log is a representation or a record of what happened within the organization during a certain period of time. In this lecture, we are going to consider what-if scenarios. If an organization wants to check what would happen on their performance if they increase the number of resources, or if the workload has increased, or the arrival rate of the cases has been increased for a specific duration of time, which happens during a season, what would be the impact of these kind of scenarios on the performance of the process? So in the process simulation, we assume that we have the PPMN model of the process that you have inside your organization. This PPMN model can be an initial design for the process inside your organization, or you can export it from the event log that you have recorded during a certain period of time. And after that, you define a simulation scenario. You define a simulation scenario such as increasing the number of resources inside your organization, or changing the workload within the organization, or changing the working schedule inside the organization. Then we run the simulation. The simulator generates as an output an event log that simulates what happens inside the organization for this scenario. And after that, we analyze the output of the simulation in order to check for stuff like the resource utilization, the costs, the waiting time of the cases, and other analysis as we have been doing during this course. And after that, we are going to repeat this kind of simulation for different scenarios until we reach a situation that we agree that situation fits the organization. To simplify the explanation of the process simulation, let's assume that we have this event log of a credit application within an organization, within a bank. The application goes through, in parallel, check credit history and the check income sources. And then there is an assessment application, which is a decision-making point. And after that, the application can be granted. Then you make an offer for the application, or you can deny it, which is you notify the rejection and you receive a customer feedback. Sometimes it got reviewed, and sometimes you just end the application. So this is the PPMN model of a bank that performs a credit application handling. Let's assume that given this PPMN model, we need to generate an event log. To remind you, an event log is a case identifier, a sequence of activities that has been executed for that case, and the timestamp at which every activity has been executed. So we can do a very simple thing. First, at the arrival time of a case, let's say that we have a case arrives every 20 minutes. So every 20 minutes, we got a case, we generate a case identifier for that case, and then we have a token. The token goes along the process model. So the token goes in parallel to both the check credit history and the check income sources, and then the token goes through the assessment, the assess application activity, and after that, the token can go through the make credit offer or the notify rejection activity. This decision making, it depends on a probability. Let's assume that we have a coin, and for every application that arrives, we just toss a coin. If the coin is a head, we just perform an offer, and if the coin is tail, we just reject the offer. Luckily, it doesn't happen like that in real life. So based on this probability, which is 50%, it goes to the make credit offer, and 50% it goes to notify rejection, and then we continue the token until it reaches the credit application processed. This sequence of activities, it can represent the trace variant of the case. So we have this case ID is attached for this trace of activities. So the trace is check credit history, check income sources, the assessment, the make offer. That can be a trace, or check credit history, check income sources, assessment of the application, then notify the rejection, then receive the customer feedback. That can be another trace. These traces can happen inside your event log. So now we can generate traces. And then we need to generate the timestamp attribute for the event log. The timestamp attribute represents the execution time for every activity. So we need somehow to set the execution time for the activities. Let's assume that every activity has a specific or fixed duration of time. So the check credit history, for example, it takes 6 minutes. We can make it fixed. This one takes 10 minutes. Let's make it fixed. This one can take like 20 minutes, and so on. And through that, we can generate the timestamp. So the credit application arrives at 10 a.m. in the morning, and then the check credit history happens after that with 6 minutes. This one happens after that with 8 minutes. And after that, this one executes, and it ends 20 minutes after the 10 minutes. So after 30 minutes, so 10:30, this one has been ended, and so on. So we can now label the execution timestamp for every activity. That is very simple. So we agree that there are some certain parameters or components that we need to provide for this model in order to be able to generate event log. These parameters can fit into the simulation model. Let's see in details. First, what is a processing time of activities? In the previous example, we assumed for simplicity that all the activities comes with fixed value. However, this is not the case. In real life situation, the activity execution time differs from one case to the other, but it comes from a distribution. Sometimes the distribution is fixed when you have a systematic task. Sometimes the distribution is normal when you have a well-defined task like checking the completeness of an application. You have a specific to-do list that you need to do, and after that you can say that the application has been already checked. So this to-do list can be represented as a normal distribution. The normal distribution can have a mean value and a standard deviation that represents how the deviation of the duration will be from the mean. And the last distribution can be exponential, and the exponential distribution can represent a decision-making activity inside the organization, such as the assessment of an application. Since the decision-making takes longer or it differs, it depends on the application itself. The employee will need to check the risks of this application, checks everything around this application in order to decide whether to accept this application or not. So the exponential will fit a decision-making activity. So now we have distribution, and from each distribution we can bring or can draw a value for the execution time for the activity. So for our example, we can set the check credit history to be a normal with a mean 10 minutes and a standard deviation of 2. The check income sources can be a normal distribution and of 20 minutes on mean, and the standard deviation can be 4. The assessment application is 20 minutes and it's an exponential distribution. And the make credit offer, it's 10 minutes and it's normal because it's a robotic one. And the notify rejection, it's normal because it's also a repetitive one. And receive customer feedback is going to be executed by a software and which takes fixed amount of time. The fixed time here is gonna be 0 because the software here is fast. The second parameter or element of the simulation model is the conditional branching probabilities. The conditional branching probabilities in the previous example, we represented it as tossing a coin. However, this is not the case. You can study your event log and then, based on the probability distribution of the edges after the branching point, you can set the branching probabilities for every branching gateway in your PPM model. So this is the conditional probability. You can get it from the data. The arrival rate of process instances and their probability distribution. So you need to calculate how much cases do you have and what is the inter-arrival rate. What is the time between two consecutive cases to arrive into your system. Also, you need to consider the calendar for the arrival calendar of cases. Sometimes cases arrives on Monday more than on Friday because of that, we can just bring the exponential distribution to represent that behavior. So you need also to set the arrival rate. The arrival rate can be calculated from the event log that you have inside your organization. For example, for our previous model that we have, we can set the branching probability to be 30% of cases will get the offer and 70% of the cases will be rejected. From those 70% of cases, 30% will be reviewed and 70% will just be ended. So this is the probability of the branching probability. And then for the arrival rate, if we have 2 applications per hour, that means we have half an hour between every 2 consecutive applications. So we can represent that using exponential distribution just because on Monday sometimes we have more applications than on other days. So you need to consider the calendar into your distribution too, into your arrival rate distribution. So this is for the arrival rate and the branching probability. The fourth part of the elements of the simulation model is the resource pools. Resources inside the organization can be of a specific amount of people, and it costs you an amount of money. For example, in this credit application business process, we have 2 types of employees or 2 groups of employees. The first one is the clerk, which is a set of people, and they work from Monday to Friday from 9 a.m. till 5 p.m. They cost 25 euros per hour. And we have another set of resources, which are the credit officers. They work for 35 euros per hour, and they work from Monday till Friday at the same from 9 a.m. till 4 p.m. So they have their own calendar, and the clerk, they have their own calendar. We need to assign every activity to a specific resource from the pool of resources there, and we need to consider the number of resources inside our simulation, because if we have more resources, we will have more cost, and we sometimes can have lower waiting time. However, if we have lower resources, for example, sometimes we have a larger or more waiting time than with more resources. So the resource pools, we need to consider that for our simulation model. So in our example, we can assign the credit history, check credit history activity to be executed by a resource from clerk pool, the check income sources to be assigned for a resource from the clerk pool again. The assessment of the application can be executed by an officer. The make credit offer can be executed by an officer. The notify rejection can be executed by an officer, and the receive customer feedback can be executed by a system, because it's a system admin or a system that represents a software. This kind of assignment can be found in the documentation of the business process inside the organization. So now we have built the model, we defined the simulation scenarios, and we will run the simulation itself. After running the simulation will give us an event log that simulates what happened inside the organization for these scenarios that you defined for the simulator. And after that, we perform the analysis for these parameters, and then we repeat until we reach the simulation scenarios that we agree with. We can analyze this kind of analysis using different methods inside Apromore. For example, you can perform the dashboard analysis as we explained earlier in the previous lectures, and also we can use the animation in order to find the bottlenecks inside our system. In the next video, I'm gonna explain how to do that inside Apromore and how to generate the simulation output from the simulation scenarios that we have. See you in the next video.